In this video, we're going to look at user authentication with Ethereum wallets using Stytch. Hey everyone, Wes here with Productive Dev. I hope you're doing well. I'm really excited for this episode because we're going to look into a very interesting topic, which is the idea that we can authenticate users for our web applications using crypto wallets. And specifically, we're going to be looking at how we can use Stytch, which is a passwordless authentication platform, and MetaMask, which is an Ethereum wallet that we can set up to actually authenticate users into a Vue 3 and .NET 6 web project. Now, you may have seen a video that I made just a few weeks ago about passwordless authentication with Stytch, in which we set up a magic link setup where users could place their email addresses into a login form, and Stytch, on behalf of our web application, would send our users a link to authenticate with the application, where when the user clicks on the link, they're brought back to our application in an authenticated state. And we looked at both the front end from a JavaScript and Vue.js specific perspective, and a .NET 6 web API backend that we built to actually do all of the communication with the Stytch platform via Stytch's API. In this video, we're going to use the same application that we looked at previously, except we're going to take a slightly different approach to the type of authentication we're going to set up. So Stytch actually offers the ability to do passwordless authentication in a number of different ways. We've looked at the magic linked authentication flow. In this video, though, we're going to focus on something really interesting, which is the ability to authenticate with our application using the blockchain, specifically with an Ethereum wallet. Now, full disclosure, Stytch is sponsoring this video, but I want to note that I really only work with sponsors on the channel whose products that I really enjoy using, and I have genuinely enjoyed using Stytch's API over the last month or two. I find their API documentation to be very thorough. It's a very developer-centric platform. It's really easy to integrate into new web projects, which is something that I'm working on quite frequently. So thus far, I found Stytch to be a fantastic platform to work with, and I've been really excited to explore a number of different features, such as this login with crypto wallets feature that we'll be looking at in this video. And as always, patrons of the video who support the channel via Patreon get access to all the source code for this and every video that I make on Productive Dev. And even if you don't support the channel, thanks for watching. I hope that this content is valuable for you, and I hope that you enjoy exploring new modern ways of authenticating users in your application using a passwordless approach, whether that be through magic links or, in this case, through crypto wallets. So thanks for watching. Let's dive in and take a look at setting up passwordless authentication using crypto wallets with Stytch. Okay, so let's get started here. There are just a couple of steps that we need to make sure that we take care of to ensure that our users can authenticate with a crypto wallet. In this case, we're going to enable our users to authenticate using Ethereum. And for this, we're going to use MetaMask as our wallet. This is a wallet that integrates directly with Firefox. There's also a plugin which integrates directly with Chrome. And so if you head over to metamask.io and then click download, you can see that you can install it, as I mentioned here in this case, for Firefox or for Chrome. There is an extension. You can also install it on iOS or Android. In our case, I have it installed in Firefox already, but we'll click through here, and we're just going to download the extension, ensure that it's properly installed, and once it is, if you're using Firefox, you should see it in your toolbar here. And you can see that I've logged into an account. I have an Ethereum wallet here with exactly 0. So go ahead and install the MetaMask extension for the browser that you're using, and ensure that you can create or authenticate with an existing Ethereum wallet. Now we're actually going to use this wallet when we authenticate with the application that we'll be building and integrating with Stytch. And so Stytch is going to allow us to authenticate with this crypto wallet and abstract away much of the complexity of authenticating our users using a blockchain. And so we're going to head over into our Stytch dashboard. Now, if you saw the previous video I did where we built a magic link integration using Stytch with our Mindful Gifts gift shop application, we're going to be using the same application again here, except we're going to be swapping out the authentication method, in this case to use crypto wallets with Stytch instead of the Magic Link integration. And we'll see that it is just as easy, if not easier actually, to get set up with a crypto wallet authentication. So if you don't have a Stytch account, go ahead and set one up for the purposes of this demo. Your Stytch account will be free if you use your email address that you're authenticating with, and so you can get set up very quickly. And once you are set up, we'll head over to the docs. And similar to the previous video where we used an API within our .NET project to work with Stytch, we're going to be working with that API again. So we'll head over to the API documentation, and we'll head down to crypto wallets, which you can see at the time of this recording is still in beta. Now you can see that there are just a couple of endpoints that we'll be working with. One to start our crypto wallet authentication. We'll look at how we wire this up shortly. Essentially, this is going to be the initial step of authenticating our users. This is going to essentially require our users to sign a message. And then once they're authenticated, or once we've started that authentication process, we're going to need to complete it by invoking a second endpoint that we'll make a post to, which essentially just completes that authentication by passing along that signature. So we'll take a look at how to set all of this up. Stytch itself does not yet have instructions or examples using .NET, but you can see that there are examples here using a sort of straight up curl request. There are also examples for Node, Go, Python, Ruby, Kotlin, and Swift. In this video, though, of course, we'll be integrating the solution into a .NET project. So let's take a look at how we can do that now. There's going to be two parts to this. There'll be the .NET solution, which is our web API that will be interacting directly with Stytch. And then we're going to have our Vue 3 application running on Vite, which will serve the front end of our application. And we'll be using the same app that we did in the previous video where we integrated a Magic Link solution using Stytch. So let's take a look at that project directory now. If you don't have it set up, feel free to check out that previous video. It's a very small project and it's sort of just enough to get started with some type of UI for our gift shop. We're essentially going to be reworking that application to use this new crypto wallet authentication with Stytch rather than the Magic Link integration. So I'm going to head over to the project directory now and we'll make sure that our project is running. So here we are in the project directory. If you're not familiar with the project yet and haven't had a chance to check out the initial video where we work through this project the first time, basically we have a client directory and a server directory. Our server directory contains our .NET solution, which is our web API, and our client directory contains that Vue 3 project. So I think the first thing that I'd like to do here is just head into the client directory. And now we're going to take a look at what's in this directory. We have a Mindful Gifts subdirectory, so we'll move into this directory. And here is really the root directory of our Vue project. Now, if you take a look at what's in the package.json file, you can see that we have a minimal number of dependencies here. We're using Vue, Vue Router, and Vuex, and that's really it. We have a number of dev dependencies because we're running on Vite. We're using Tailwind and TypeScript, but really just a minimal project, and we have a number of different npm scripts that we can run. So let's just run npm run dev, which is going to start our Vite server. So let's say npm run dev. This is going to start our application on port 3000. So let's pop open a browser and see what we have. Okay, so here we are. We have a storefront, and what we have is essentially the UI that we built in the initial video where we wired up sending magic links to our users. What we're going to do is now sort of repurpose this and imagine that we want our users to authenticate and use their crypto wallet, their Ethereum wallet with MetaMask when they enter our gift shop. And for this, we just need them to authenticate using their crypto wallet against the blockchain. And Stytch is going to be instrumental in really taking care of much of the complexity of that and just giving us a few simple API endpoints that allow our users to authenticate themselves using their preferred crypto wallet. So we're going to take a look at setting things up on the front end in terms of calling our own API, and then looking at the new API endpoints and the new service that we'll build in .NET to support that workflow. So I think I'd like to start here from the front end, but before we get too far along in the code, we should go ahead and look at how to start our web API as well. So for this, let's head back to the terminal, and I'm going to open up a new tab here and head back into our project directory. And here we're going to move into our server directory, which you can see contains our .NET project. So here we could run .NET run to run the application, or we could attach a debugger from our IDE. It's really up to you, but I think I'd like to attach a debugger in this case. This will be useful when we are debugging our front end and back end code in just a few minutes. So let's go ahead and do that now. So I have the code open in Rider here. It's just a single .NET Web API. Again, we looked at this in the previous video. What I'm going to do is just right click here and select Debug Mindful API. Okay, so now our API is running. And so we have a working backend for our application. I'm going to allow access here temporarily. And let's take a look, first of all, at how our users are going to interact from a client-side perspective. So for this, I'm going to open the front-end code in Visual Studio Code. So here we are in our simple Vue 3 project in Visual Studio Code. You can see that it's a very small Vue project. We have a source directory here that contains a number of subdirectories, notably our pages subdirectory, which contains our two main Vue components, a login component, which of course enables our users to log in, previously using magic links. So you can see that essentially this page contains a method to send a magic link to our user's inbox, which is basically proxying a request from, through our backend here at an endpoint at localhost 8080/create or login, and then our backend is making a request and communicating directly with Stytch, which it shares a secret with on the backend, so that our users can actually, in this case, be created or log into their existing account. And so that's essentially how we set things up in the magic link video. Now we're going to be changing the UI a bit here. You can see this is the UI for the login page. We have this button which, when clicked, invokes our send magic link method. We're going to swap this out to enable our users to instead authenticate by signing in with their MetaMask extension, in this case in Firefox, and authenticating against the blockchain. And this is going to then essentially enable them to view and use their wallet directly within our application. Now, Stytch is going to essentially abstract away much of the complexity that's required when enabling this authentication with our users against the blockchain, essentially boiling it down to just two API endpoints that we can work with on our backend in much the same way that we worked with the API on our own backend when we did the magic link integration. So our users don't need to be authenticated to visit the login component, but they do need to be authenticated to visit our storefront, which is the home component. And in the previous video, we took care of all of this authentication logic using an auth guard. So within our auth guard, we have a number of important things happening here. First of all, if the user visits our application with a session token in a query parameter, basically this happens when they're sent back to our application from their Stytch email, we basically take that token off of the query parameter and push it into local storage for the purposes of this demo. Then our users can pull that data from local storage when they make subsequent requests and need to check whether or not they're still authenticated, and then can proceed to a particular route. Then we have all of the logic to check whether or not a user can actually and should actually continue given that they have or do not have a session token. And we used a special endpoint that we built in our own backend called verify token, which takes that token and then essentially proxies that entire request with the token, making a post to Stytch's API to basically say, hey Stytch, here is what the user provided. Are they still authenticated? And then Stytch would return some response to us, either saying yes or no. And then at that point, we handle the user experience, either allowing them to visit the route that they would like to visit or denying that request. And so that's how we set up all of this logic in the initial video. You'll note that we also, in this case, get back from the previous implementation a list of user emails. So the user may have multiple emails. Stytch can actually send that data back for a particular authenticated user. In this case, we're going to look at how Stytch will send us back a user's crypto wallets. And similar to the way that we basically committed those emails to a very simple store that we have in this application, we'll look at now how to set a user's crypto wallets to some state that we have set up in the Vuex store. So I think the first thing to do is let's head back to our login, and we want to make some modifications to the button that our user uses to log in. And so the way that I'd like to do this in this particular case is just to replace this button with our new implementation. So what I'd like to do here is to start with the login.view component, and we're going to have our button, rather than invoke a send magic link method, what we're going to do is we're going to say start Ethereum auth. And rather than have the send message value interpolated here, what we'll just say is something like login with MetaMask. Okay, so we need to actually create this method. So let's head back up. In this case, I have the script section up here. And you can see previously we had defined this send magic link method. Now we're going to define a method called start Ethereum auth. And if you recall back from the docs we looked at a moment ago on Stytch, we can see that we basically have to invoke two separate endpoints here. One to start our crypto wallet authentication, which it says upon calling, the user will need to assign a message containing only the returned challenge field, which will come back in response from this request. And then we need to basically call authenticate to authenticate that crypto wallet, passing along that signature. So the way that we're going to set this up is, first of all, we're going to check whether or not a user has MetaMask installed. And at the time of this recording, what we can do is basically just say if there is not an Ethereum object on the window itself, then we're going to return false. So this is going to be true when a user actually has MetaMask installed. And so now we want to actually query our user for any Ethereum accounts that they have once we know now that MetaMask is actually installed. And so we can get the address by awaiting window.ethereum and we can call request here, specifying a method with the name eth_request accounts. Okay, and if we want to see how that works, we can just, for now, let's go ahead and console log that address. So at this point, we have started a method called start Ethereum auth, and that gets invoked anytime we click the new button that we have, login with MetaMask here. So let's click the button and see if we can actually, first of all, determine whether or not MetaMask is actually wired up and working with our Vue application. I'm going to go ahead and open the inspector here. And we'll click login with MetaMask. You can see that when I did this, we now actually get that address out to our console. Let's go ahead and log out. So if we're already logged in here, what I like to do is sign out. So I'll disconnect this account actually. And so now we see that MetaMask is not connected to this site. And so we'll click Login with MetaMask again. And you can see now it's asking us to connect with MetaMask. And so we'll go ahead and say next. Otherwise, if you don't have the option here, then you can just go through and create a new account. But I'll say next, and we'll say connect here. So now you can see that MetaMask is actually connected the particular account we chose with this particular site, which in this case is just localhost running on port 3000. Okay, so we know that we can allow MetaMask to connect and associate our wallet with this site, but now we'd like to use this to actually enable our users to authenticate with our application, and this is where we're going to start our Stytch integration. So what I'm going to do here is in a try-catch block, we're going to use the Fetch API to make a post request. We're going to use the Fetch API to make a post request to our API running on port 8080 to a new endpoint that we'll create called auth Ethereum address. This is going to be a post request, and here we're going to send on the post request body of this HTTP request an object that has an address property with a value of the address that we have now connected with MetaMask. So we're making this post request to an endpoint that we're in control of in our server, in our case written in .NET 6. Then we're going to get the result from this simply by awaiting response.json. This response is actually going to contain a challenge on it, and we're going to take that challenge along with this Ethereum wallet address, and we're going to post this back to a second endpoint in Stytch, which is actually going to complete the authentication process. And for this, we can actually invoke a method on the global Ethereum object, or the object that's on the window, by invoking Ethereum.request. So the way this is going to look is we're going to get a signature back here. So we'll call this constant signature. We're going to await Ethereum.request. The method is going to be personal sign, and the params in this case are going to be an array object whose 0th index here is that challenge, as I mentioned, which will be on the response that we get back, as well as the user's address. This should produce a signature for us, and we can double check that with console.log here. We'll say signature. And here, just for the sake of debugging clarity, we can call this address. And this signature is precisely what we want to send a follow-up request back through our backend. So we'll take this signature as well as the user's crypto wallet address, and essentially this will help us complete that authentication flow with Stytch. So the user is now providing a signature along with their wallet address, authenticating their identity. This allows Stytch to essentially complete this process using a user's crypto wallet and their signature. So you can see that this post request will be now sent to localhost 8080 /auth Ethereum address signature. So auth Ethereum address will essentially handle that first step of initiating this authentication workflow, and then our second post endpoint auth Ethereum address signature will complete the process after a user has essentially signed this request, given the challenge that comes back from that initial request, and sends now that signature along with their wallet address back through our API and to Stytch to complete the authentication flow. So again, now from this we'll get a signature result back. So we'll say let signature result equals response.json, and we'll await this. And what's going to come back here in this case is actually a session token, which is just what we can use to make subsequent authenticated requests. And we'll also get back a JWT that we can inspect that may contain additional data, additional user claims that we have, and we can take a look at that shortly. So we can take a look, we can log that out. So we can say like console.log, signature results, but here, for the sake of the demo, what we're also going to do is store that data in local storage. So we'll call local storage.setItem, let's say session token here. That's going to come back on our signature result as a property called session token. We're also going to set a JWT here in local storage. Call this mindful JWT. And that's going to come back on a property called session JWT from our second post request. After this, we'll simply push our user to the home route. So for this is actually router.push. And for now, we're going to handle any errors in the meantime by catching them, and we're going to log them as a warning for right now. And so to recap, what we're looking at here as a first pass is that we have set up a new method to start Ethereum authentication. We're essentially going to check whether or not a user has MetaMask in this case installed, in which case they'll have this global or this Ethereum object attached to the window. If they don't, we're simply going to return false from this. We could say like console.warn to do handle UI when user does not have a crypto wallet. If we were thinking about the UI, we may essentially consider only rendering a button to authenticate with a crypto wallet if a user has the plugin installed. There's a lot of interesting discussion around UI for Web3 applications. This may be a bit beyond the scope of this particular video, but it's something that we would want to consider here. How do we handle the case when a user just simply doesn't have MetaMask or a similar compatible Ethereum wallet installed? When they do, we're essentially going to invoke Ethereum.request using the method eth_request_accounts to get a user's address back, in this case, as a single address. And we're going to log that just for debugging purposes. Then we're going to use that address, make a post request to our backend, which is going to initiate the crypto wallet authentication flow with Stytch. This is going to return to us with a challenge that a user basically will sign. And so the user is going to essentially post back this challenge and their address to a follow-up endpoint to essentially complete this process. So it makes this round trip back to our user, and then we post back this signature, which we get by supplying the challenge and the address to window.ethereum.request with the method personal sign. So the signature, along with the user's Ethereum wallet, is then posted back through our API, at which point, again, we invoke the second and final Stytch endpoint to complete the authentication using a user's crypto wallet. We get the signature result back, which we're sort of in charge of controlling the shape of, depending on all of the data that we can get back from Stytch through our own API. And in this case, we're going to look at how to return a session token, which a user can then make subsequent requests to as authenticated users, as well as a JWT. So the session token is going to be used in just the same way that we use the session token with Stytch when we set up our Magic Link authentication flow. This time we also have a JWT to look at and to work with, so we'll look at that as well. And then finally, once this is complete, we'll just push our user to the storefront, which in this case is our base route. Okay, so now let's go ahead and set up our two new endpoints on our own backend here and test things out. If we're to test this out now, what we'll see is we just simply get an error. Even though our application is running, there are no routes really to work with. So we're going to go ahead and refresh here. And we do have a little bug here, which is the redeclaration of the const response. So let's go ahead and fix that error. And I can see that here. Let's call this one signature response. And we'll save that and head back into our browser. And now if we try to log in with MetaMask, you can see, though we have an address, which is fine, we cannot make a post request to an endpoint that currently does not exist, which is our auth Ethereum address. So let's go ahead and wire that up now. Okay, so we have our .NET 6 application open here. As you may recall, this is built as a .NET 6 minimal web API, which is a new paradigm in .NET 6 and essentially allows us to use a single file, or program.cs here, to create the entire web API. We have the ability to wire up dependency injection here for some of these services that are in our service layer, if you will, our business logic layer. And we also have the ability to create our endpoints directly in this single file here. So we are mapping several post request endpoints here that were set up for our Magic Link integration. We can see here. So as well as the ability to verify a token, which can be invoked whenever a user needs to, whenever we need to check whether or not a user is still authenticated by verifying a token that they post back to us. And we also have the endpoint, which is our basic auth endpoint, where a user has a session token in their query parameter that we see here. We redirect a user to localhost port 3000 with that session token in their query parameter when they come back from that Magic Link email authentication flow. So here we just need to add the two endpoints that we set up now to handle our crypto wallet authentication. So we just have two endpoints to set up. And so let's look at how we might do that now. What I'm going to do is just start kind of a new section down here, and I'll also stop the debugger. We're going to call this off with Ethereum. Now, even though this is a .NET 6 minimal web API project, you could still very easily set up a sort of more standard MVC style project and have a controllers subdirectory here and have your endpoints created in traditional .NET Core controllers. For the purposes of this video, it's a very small API. It's kind of a good use case, I suppose, for using a .NET 6 minimal web API, so that's what we'll do here. We're going to create a post endpoint. At our auth Ethereum address route. And we're going to create our callback function. So this is the first endpoint that we need. And the second endpoint that we need, we call it auth Ethereum address signature. So again, just refreshing this, these two endpoints here correspond to our first step here, where we're going to need to tell Stytch to start this authentication flow, and our second, where a user will be sending back their signature along with their crypto wallet address to complete that authentication flow. So in the first case, what I want to grab is an object from the body of the post request. So we can say from body here. This is going to be of type Stytch Auth Ethereum request, which will be a new type that we have to create. Call this auth request. And the second parameter here will be a new service that we'll create called iStytch Ethereum service. And I've made these types now. We'll review them, or this type anyway. And we'll need to create the Stytch Ethereum service here momentarily. So the way this type looks is very simple. It just simply contains an address. And so we create this as a string property on a plain old C# object here. And we have the attribute JSON property name, which just tells us that it's going to come in here as lowercase address. So essentially what we want our Ethereum service to do here is to authenticate an Ethereum address. Remember, it's going to send back a challenge that a user is then going to take, and we're going to use MetaMask to sign it and send it back with that signature to our second endpoint here. So not to get ahead of ourselves here, what we want to do is get some response from this service. So we'll say Ethereum service. So the method is simply going to be to authenticate the Ethereum address. And we're going to grab the address off of that auth request. And then we're going to say, is that response successful? And we're going to return an OK with the response. Otherwise, we're going to say results.unauthorized, just to keep things simple for now. Okay, so let's go ahead and create our Stytch Ethereum service. Now, for the sake of simplicity for this small demo, I have simply a namespace in the single API project here for our business logic. And so under the auth directory here, what I'm going to do is I'm going to create a new class called Stytch Ethereum service, and we're going to define an interface, iStytch Ethereum service, that is implemented by our Stytch Ethereum service. Now our method here is going to be an asynchronous method, so the interface will define a task, and the type is going to be a crypto auth response that we'll take a look at here. This is the type that we'll create. We'll have authenticate Ethereum address. So let's go take a look at this type. This is going to have our Boolean value, the flag, to determine whether or not this auth response is successful. We're also going to have a status code, which is just an HTTP status code in this case. We'll have a nullable string challenge and a nullable string user ID that can also be sent back on this auth response. So let's set up our service here. We'll have some backing fields, including our Stytch options object, which we used previously to configure our things like our session URLs, magic link URLs. In this case, we're also going to add a new property for our crypto wallet auth URL. So be sure to add that here. And as you may know from previous videos, this is going to be, this configuration will be implemented using the options pattern in .NET. We'll be able to basically map our configuration values to these strongly typed objects, in this case a Stytch options object that we can use in the context of our code. So if we take a look at appsettings.development.json, we're going to set up our crypto wallet auth URL with a value of https test.stytch.com v1 crypto wallets /authenticate. So this is just for convenience purposes. This is the basically endpoint that Stytch provides us in their API documentation for authenticating a crypto wallet. It's also the prefix for starting the crypto wallet authentication. So in this case, I'm just going to use sort of the base endpoint, if you will, and then we'll append the /start the leaf node of this path, if you will, when we need to start the authentication. But I've put it in our config here for convenience purposes. I should note here, although it should go without saying perhaps, that we shouldn't be storing secrets in our app settings files. This is something that we should be using a secret storage solution for, something like AWS Secrets Manager or HashiCorp's Vault. But for the purposes of the demo, we're putting them here for convenience. This is definitely not a good idea for any type of production, staging, test environment, anything like that. We're simply using it here to make things a little bit easier from a demo perspective. If you have signed up for Stytch for the first time in this video, then be sure to grab your project ID as well as the secret from your Stytch account, and I can show you how to do that now. So back at the dashboard, you want to open up the project that you have, and then you go down to API keys, and you'll see your project ID here as well as the secret, which you can view and copy. It should be copied here for the purposes of the demo into our app settings.config. But this is not how you would store a secret value in production. Again, for this, we would use a proper secret storage mechanism for that. Okay, so let's head back into Stytch Ethereum service. We're going to go ahead and create our constructor and assign values to those backing fields. I'm using the options pattern here to wire up our configuration for our Stytch options object, and we'll go ahead and implement our interface. Now here, things are going to be quite simple, and we'll walk through this line by line as to exactly what's happening here. We're going to essentially take this address that we've been provided. We're going to log out to, in this case, using our basic logger, that we're authenticating this address. We're going to create a new HTTP client instance using the HTTP client factory that we've injected, and we're going to assemble a new Stytch crypto auth request payload. So this auth request contains three properties: a crypto wallet type string, a crypto wallet address string, and a user ID string. So our crypto wallet type in this case is an Ethereum wallet, and the address will be, of course, the public address of a user's crypto wallet. Then we're going to basically serialize this data using JSON serializer so that we can use it to make a crypto auth request out to Stytch. And so this will be a new private method that we build momentarily. Basically, it's going to take that URL, that first URL from Stytch's documentation where we need to start the authentication process with the serialized payload and the HTTP client to go ahead and make that post request. If we have an exception during this process, we're simply going to return a crypto auth response with a is success false and log an error that there was an error while authenticating this particular Ethereum address. So let's go ahead and create this method. And this method looks a little more complex, but really it's pretty straightforward. We need one more private method to build an encoded auth string. So we'll walk through this now. Basically, all we're doing is we're taking in that URL, which is Stytch's URL for starting the auth process in this case, that serialized payload, which we serialized above, which is simply a payload containing a wallet address and a crypto wallet type of Ethereum. We're going to build an encoded auth string. This is just a base64 encoded auth string that contains the Stytch project ID and the Stytch secret that you have that you can get from your dashboard separated by a colon. And basically we're creating a base64 encoded auth string from that, and then assembling our header, our basic auth header here with a basic prefix and that base64 encoded string, and returning it. So in fact, this can be simplified here, which is just like this. So we're building this auth string, and then we're creating a new HTTP request method with the headers that we created, or the auth header that we created, this basic auth header, and an accept header of application JSON, making this a post request to that URL, with a string content value of that serialized payload. We're then simply making this request, we're sending this post request, and we're reading from JSON, deserializing that into a Stytch crypto auth challenge response object. So this is what Stytch will send us in return here. It's going to be a very simple object containing a string with the challenge, a request ID, the user ID, the HTTP status code, as well as whether or not the user was actually created in this case. Okay, so if it's a success and the response that we get back is not null, then we had a successful authentication event with an Ethereum address. So we're going to return this as a crypto auth response with that challenge, the status code, and a success flag set to true. Otherwise, again, we're returning a crypto auth response with that success set to false. So this is all coming from our make crypto auth request, and so this is sort of a wrapper method around invoking Stytch directly using our HTTP client and making that post request and getting that challenge back in return. So if we come back up here, by the way, this crypto wallet.ethereum is simply a wrapper for a string Ethereum, so we could have other types of crypto wallets here eventually. So we've made our crypto auth request and essentially just returning that directly from the caller of this method. Otherwise, catching an exception here, and again, returning is success false. Okay, so authenticate Ethereum address is wired up, and assuming we get a successful response back, we return a 200 response back to our client. Otherwise, we return a 401 unauthorized response. Now, if we sort of follow the train of logic here, we can see that we're essentially going to make that request here, and we're going to get the result.challenge off of that HTTP response that comes back, and we're immediately going to pass that to window.ethereum.request, which is going to invoke this personal sign method. So we're going to get that result back, which, as we just saw, will have this challenge property on it, hopefully, and we're going to use MetaMask here to invoke this personal sign method with those two params passed as an array here, the result.challenge that comes back, as well as the user's crypto wallet address. If this is successful, we should be able to see this signature directly in the client. We can log that out, and we're going to immediately turn around and take that signature and post it back to our second endpoint with the user's crypto wallet, and then complete that with Stytch. So let's go ahead and set that up now. We'll head back into our .NET project. This one here is going to be pretty simple. Here from the request body, we'll have a type Stytch crypto auth signature request. We'll call this sig request. We're going to use our Stytch Ethereum service again. And things are going to look remarkably similar, except that we'll have a second method to call here, which will then invoke our second endpoint with Stytch. So we're going to call this authenticate Ethereum address signature with the auth request. And assuming we get a success response back, again a 200 back with the response, otherwise unauthorized. So this is actually our sig request. Our Stytch crypto auth signature request, again, contains the crypto wallet type, address, signature, and in this case as well as session duration in minutes, which will tell Stytch how long we actually want this user to remain authenticated, which is a nice convenience. So let's go ahead and create this method. Here, a public task, in this case, crypto auth signature response. We take a look at the response. This will have an is success flag, a status code, And in this case, we'll have a user ID, their session token, which they'll use, of course, as an authenticated user, as well as a session JWT that we'll take a look at shortly. Let's go ahead and implement this method. Now this one will actually be quite simple. We're going to log that we're authenticating a signature. We're going to create a new instance of an HTTP client again to interact with the Stytch API. We're going to basically set a SIG request crypto wallet type of Ethereum here. I want to control this on the server side explicitly, and then set a session duration minutes, which we also control explicitly here on the server side. And I have configured this in our Stytch options object. You could configure this directly in the code. I've chosen to set this up as a configured value. We're going to serialize the payload, which in this case is our SIG request object itself. And then we're going to try to make a request out to Stytch using a private method that we'll create here. This is going to take our crypto wallet auth URL from our Stytch options object. This is going to be mapped directly from our crypto wallet auth URL that we set up in our app settings file. We can see that as the test.stytch.com v1 crypto wallets authenticate. It takes our serialized payload, of course, which is just our signature request that we've built up, and it takes the HTTP client. So let's go ahead and make this final private method. Okay, and this is actually going to look pretty similar to our make crypto auth request. We are just interacting directly with Stytch once again here, except now we're going to read the result into a Stytch authentication response. But if we take this one step at a time, I'm going to change the parameter name here to just URL. Again, we're building our encoded auth string. We're assembling our HTTP request method for that URL with our basic auth header value header and the accept application JSON header, and the serialized payload is the content on the request. We're sending that out now to that second endpoint, and we're getting a response back, reading that into a Stytch authenticated response. Now this is a response that we actually set up from the initial video. This is the same shape that we're getting back when we're authenticating with Stytch, generally speaking. And so this worked as well when we were authenticating using our Magic Links workflow previously. But we'll get the request ID back, the status code, and now notably we'll be getting back a session and a session token. We're also now going to get back a session JWT object. So let's look at how we're going to end up using that. So we get this object back, gets deserialized into this Stytch authenticate response object. And if we have a success status code and response not equal to null, then we have a successful auth with the Ethereum address. Here we're now returning a new crypto auth signature response, this time containing our session JWT, the session token. We'll set the success flag to true, and the user ID here, got this wrong, status code of the response.status code. So our signature response coming back here is just a very simple plain old C# object again. And we just essentially return this to the caller of the method. Otherwise, again, returning a new crypto auth signature response with that is success flag set to false. Okay, so that's basically all of the logic for the private method, which is actually returned directly to the caller of the public method. And again, if this for some reason somehow throws an exception here, we will again just ensure that we return an is success flag false on our crypto auth signature response. So this comes back up into our controller, if you will, or our, in this case, our minimal web API endpoint, and then hopefully returns back a 200 response here for a successful authentication flow using a user's crypto wallet. So now a couple things I want to do here is, again, for the demo, I have the secret in app settings.json. Again, never store secrets in your configuration. This is not safe for version control, certainly, and it's bad practice to put secret values in your configuration. I'm sure I've said that enough at this point, that this is just for convenience of the demo, but that generally speaking, we would put this in a secret store. I'm going to be sure I have the right project ID and secrets here. So we'll come back into our dashboard. I'll grab this, and I will actually remove this project as soon as I finish publishing this video. So be sure to use your own here. And then we'll take one more look at our program.cs. We're going to scroll back up here as well to where we're doing our dependency injection and mapping our interfaces to their implementations. We're going to make sure that we add our Stytch Ethereum service to the registry here. And if, again, you didn't catch the first video, this is where our options for the Stytch options actually get wired up here to our section of configuration labeled Stytch, which we can see once again here in our app settings.development.json. So each of the properties in this section here should map directly to a property in our Stytch options DTO here. Okay, so with that, let's go ahead and fire up the API and see if we have any issues to work through at this time. So what I'm going to do is right click and we're going to debug. Okay, so far so good. We're going to head back into the browser where our application is running. And let's go ahead and just refresh the page. That's looking good. Let's select login with MetaMask. And before we do this, maybe what I'll do is I'll set a breakpoint here in two of our service methods. So let's set a breakpoint in auth Ethereum address, so authenticate Ethereum address. And then I'm also going to set a breakpoint here in authenticate Ethereum address signature. And so let's head back to our browser here and we'll click login with MetaMask. Okay, you can see immediately we've hit our first authenticate Ethereum address because we've already essentially associated and logged in with MetaMask here. So that's looking good. Let's go ahead and just hit play. Come back to our browser. And in fact, we should see that we have a little icon here that says 1. So we're now saying signing in with my first project. That happens to be the name of the project that we have set up in Stytch. So that's this here. We're going to say sign. And now we're back and we're actually in our authenticate Ethereum address signature. So we'll go ahead and hit play here. And we'll come back. And you can see that we've now actually landed on our gift shop page, or our home page. And you can see that we are successfully logging out our signature here, our signature result, which has a success response. We have our token and our session JWT here. What I'm actually going to do is copy this entire signature result. I'm going to paste this into Notepad. I'm just going to grab this session JWT here. So we'll copy this. Remember, this is all client-side information. We're going to head over to jwt.io, and I'm going to go ahead and just paste the JWT into the encoded JWT here directly into the editor, and we can see the information that we're getting back. If it were to be decoded here, we can see the Stytch session ID, when it was started, when it was last accessed, when it expires. We can also see our crypto wallet ID and address, as well as the type, as well as the crypto wallet type here. So we have some useful information on this JWT that we're getting back. And in this case, just for the purposes of the demo, we're pushing that into local storage. So let's look at actually how to do that. We have a few more things to wire up on the front end. We've clearly authenticated, But now I think we can actually update the UI, for instance, to make use of some of the information that we have back for our authenticated user. So let's head back into our client-side code now. First thing that I'm going to do is something very simple, which is in store.ts here. What I'm going to do is create a new mutation called set crypto wallets. And we'll set state.wallets to the wallets that this mutation takes. And we have some state here for the wallets, which is just an array. Then what we can do is in our auth guard, where previously we just set user emails, let's also commit set crypto wallets with user crypto wallets, which will be a new variable, which is coming back as crypto wallets on this result. The result, if you recall from the previous video, is the response for verifying a token. So verifying a token works in just the same way that it has previously, except in this case now we have a user who's authenticated using a crypto wallet or crypto wallets, and so we actually have that information available to us now in the client. Okay, so with that, we can think about that now as we think about how we might want to change the look and feel of the home component. What we'll do, for instance, is create a new computed property called user wallets, which is just going to return store.state.wallets. Maybe we call this crypto wallets. And we'll come down here to where previously we showed we had a for loop here for a user's emails. Now we might also say for wallet in crypto wallets, wallet crypto wallet address is the key. And maybe we make this a div, and we can just spruce this up a little bit with a little bit of tailwind. And so we'll basically create an image, or with the Ethereum logo, which I've just dropped in images here. You can grab an Ethereum logo if you like. And saying your Ethereum wallet with the Ethereum wallet address here, and we're just going to loop through any wallets that the user has to display it in the UI. Okay, so if we come back to our UI, we can now see that the user's Ethereum wallet is visible in the browser. So this is the public address for that particular Ethereum wallet. And we can imagine a situation where once the user has authenticated with this wallet, we could come up with a way to enable them to purchase assets from the gift shop using their Ethereum wallet that they've authenticated with. Furthermore, if we take a look back at our Stytch dashboard and we take a look at user management here, we should now see that we have a test user who was just created at the time of this recording, and we have a user ID for them, which is sort of Stytch's reference to this user. We could then associate this user ID with a user ID that we create within our own domain, and therefore link some user in its own context in our system with a reference that Stytch has to the user ID in the system that the user actually authenticates with, which is Stytch here. So with that, I think that's a great introduction to a sort of Web3 concept in authenticating a user with MetaMask, with a crypto wallet. And we took a look here at how Stytch makes it incredibly easy to work with this concept and authenticate users using their crypto wallets, using just a few very minimal Web API post endpoints. So thanks for watching. I hope you got something out of this video. If you did, be sure to give it a like, and I would appreciate if you subscribe to the channel. Be sure to check out Stytch. They're doing a lot of very innovative, interesting things with authentication, whether it's magic links or their JavaScript SDK or the authenticate with crypto wallets, which is currently in beta, but is looking like a really fantastic, interesting solution for easily authenticating users in a variety of passwordless means. Thanks for watching. Hope you're doing well, and I'll catch you next time.